So, very good evening, student, to all of you. I welcome you all in this lecture of simple harmonic motion, lecture number 3. We are going to discuss here. Now, in simple harmonic motion, previously we have covered, if I talk about the periodic motion and oscillatory motion, we have covered thoroughly. Now, what is the periodic motion and what is oscillatory motion? That we have covered. And how to differentiate between oscillatory motion and periodic motion, that we have also covered in the previous session. Although we have seen the kinematics of SHM, simple harmonic motion, which is also derived from oscillatory motion. So there is a flow. Like firstly, you will have to study periodic motion, then it lead you to oscillatory motion, and then oscillatory motion lead you to simple harmonic motion. Okay. So let me discuss it one by one, what we have done. So firstly, I'm talking about the definition of periodic motion and oscillatory motion verbally. Okay. So you just have to listen to me what I'm saying. When a motion repeat itself after a fixed time interval, when any type of motion repeat itself with a fixed time interval, that motion is termed as periodic motion. Okay. Because it has a time period after which is get repeated. That is why we will say it the periodic motion. In mathematics, you will also get to learn about the periodic function, the function that repeat its value after time period. So that kind of function is termed as the periodic function. Okay. Now, just a second. Okay. So this is the periodic function that we have in our hand. Periodic function. Okay. Now, what is oscillatory motion then? Oscillatory motion is also a motion which repeat itself after a fixed time interval. But what is the difference between periodic and oscillatory then? How we are saying it differently? Because oscillatory motion is a to and fro kind of motion, back and forth kind of motion. Okay, one thing. Second thing, it is bounded motion. It is bound with the a mean position or a mean point or equilibrium point. It always oscillate. The body which executing this oscillatory motion always go around this equilibrium position or this mean position. That is why I am saying that oscillatory motion is the bounded motion. Okay. So we can say that all oscillatory motion are not periodic. Sorry, all oscillatory motion are periodic motion because they are repeating itself after a fixed time interval. But what we can say, all periodic motion are not oscillatory because all periodic motion are not bounded motion. For oscillatory, we need to move ahead with a move one step further, that a motion should be bound to and fro kind of motion. But we know that in periodic motion, not every motion is possible in such a way. So we can say that all the periodic motion is not oscillatory, but all the oscillatory motion is periodic motion. Got it? After that, we have learned about the frequency. Frequency is nothing but number of oscillation covered in per unit time. In per unit time. So it is given by F is equals to 1 by T or F is equals to 1 by nu is equals to 1 by T. It is also represented by this symbol, which is nu, 1 by T, where T is the time period. And time period is that time, that minimum time after which motion is get repeated. Okay. So that time is termed as what? Time period of the oscillation or periodic motion. Now, after that, what we have learned? We have learned about the kinematics of SHM, how the SHM is derived, so that we are going to revise here. So for that, we have take the general equation for oscillatory motion. This is the force equation of oscillatory motion. If n is equals to 1, then F we have minus kx, and this force equation execute the simple harmonic motion. Okay, when the value of n is 1. So we have seen here, if I take the straight line, this position, we have also defined in the previous session what how to find the equilibrium position. So for equilibrium position or mean position about which the motion is bounded, how to find that? Put F is equals to 0, where the value of force is 0. That position is termed as equilibrium position. So here x is equals to 0 is the mean position. Now, if the block is here, let's say at time t, okay, so we can say that all the distances are measured from mean position in oscillation. So this is positive. Let's say this direction is positive and this direction is negative. So here if you will see x is somehow positive value, so force will be negative because force here is minus kx. So if x is positive, then force will be negative, which means force is acting opposite to the motion. This is the force and this is the motion. Okay. Now, if I talk about this position where you can take x is equals to negative value, somehow negative, then the force will become here negative into negative of x will become positive of f, which means this force act in this direction. So you will see this force always try to capture this body which is executing SHM about mean position. It always want to attract the body towards the mean position. Okay, got it? Now, I will tell you why it is doing that. So firstly, make me clear that it is clear to you what I have said, what I have uh, did here. It is clear to you, each and everyone. Okay. So after that, what we have learned, this is we are revising only. Okay. So what we have did after that, we have taken this equation f is equals to kx, where k is a some constant. When we talk about the spring block system, then this k will become spring constant. Otherwise, it is some constant, not spring constant. So f is equals to here, we have taken kx. According to Newton's law, what we can say, ma is equals to minus kx. So acceleration will be minus k by m into x. Now, acceleration, we can write dv by dt, change of velocity per unit time, minus km by x. dv by dt ko we can write dx by dt, so it will become d2x by dt square minus k by m into x. So this is the second order differential equation that we got. If we solve it, solution of this second order differential equation, and do not worry that how to solve this equation because it is not in your syllabus. Okay, so we can directly write the solution of this equation. This will be a sine omega t plus delta and x is equals to a cos omega t plus delta. Okay, you always remember that sine and cos are harmonic function. Harmonic function. That is why this motion is termed as simple harmonic motion. Okay, because it is following these equation as their leading equation. Got it? Now This is all we have did in the previous lecture. Now move ahead with the newly establishing of this. Now, what we are going to do, we will analyze the simple harmonic motion in two forms. First in the displacement form and second in the time form. Okay. So we will got two set of equation. In the question, whatever is given, you can apply the that selective application or that selective equation in that question. Okay. Displacement equation in SHM means that we are observing the force, the acceleration, the velocity with respect to the displacement from the mean position. How the velocity is varying, how the force is varying, how the acceleration is varying with respect to the variation in displacement from the mean position. Got it? Okay. So here, if I talk about, let's say, we know that simply first equation is given to you as, you don't need to worry about the first equation, which is given to you, f is equals to minus kx. Got it? Now, so this is the first equation between force and displacement. If I talk about acceleration, so you can write f is equals to ma. So minus k by m into x. This is equation number second. If I talk about the velocity and x relation, so I have developed a method from where you can find it out easily. Now we know that acceleration is equals to dv by dt. We are using the concept of general equation of motion. Okay. So dv by dt. Now if I multiply this with dx by dx, and dx is the change in position, which is displacement. So acceleration will become dv by dx, dx by dt. I have just interchanged something. So dx by dt is nothing but v again. So a will become v dv by dx. So from here you can say a dx is equals to v dv. So this is the general equation that we have in terms of acceleration, displacement, and velocity and velocity. Okay. So this is we are going to apply here to find out the relation of velocity with respect to the displacement. Okay. Now x a dx is equals to v dv. Okay. Now to find, we need to integrate this equation and we need to put the limit also. Okay. So what we can do, when this is, let's say, the motion line at x is equals to 0, and let's say this is at some general point at x is equals to x. Okay. And moving in this direction. Now what will happen when it reaches to the extreme position? This, because the acceleration is acting in the opposite direction. We have seen in the previous slide, acceleration, force is acting in opposing the motion, so acceleration will also oppose the motion. So this acceleration will continuously decrease the velocity. The time will come when the velocity becomes 0 and this body will reverse its motion in this direction. Again, when it reaches the maximum here, because acceleration will be here in this direction by crossing the mean position, so it will be acting in this direction again. So we can say that at extreme points, these are the extreme point, the maximum displaced position of this object which is executing SHM. So this maximum displacement is the extreme positions. Got it? Now at extreme position, the velocity will become 0. So we can say when x is, let's say, some constant a, we can say. Here, the maximum displacement is a. Okay. Here also, it will be a. The maximum displacement from the mean position. So for this a, the velocity will become 0 at this point. Got it? Now, at some general point x, let's say the velocity be v. So if we integrate it, it will become, acceleration is somehow here. We can take it out. So we can put the value of acceleration here, minus k by m into x. xa minus k by m into x dx is equals to integration of 0 to v dv. Now this is very simple. K by m is a constant, so we can take it out, minus k by m. Okay. Now it is integration of x dx, a to x, and it is 0 to v dv. Now if you integrate it, it will become, if you integrate these expressions, it will become minus k by m x square by 2, and we will put the limit as x square by 2 minus capital A square by 2 is equals to, here also it will become v square by 2. If you put the limit, v square by 2 minus 0 square by 2. So that will vanish out easily. So what we have v square by 2. You can cancel out this 2 by taking common. Now this k by m, I will tell you further. This k by m is nothing but omega. Omega is the angular frequency. So I will relate it in the next slide. So it will become minus omega. Okay. Sorry, k by m is minus omega square. Now, this is minus omega square. X square minus a square equals to v square. Got it? Now, and it is also, yes. So we can say that if we take the minus from here, this minus will cancel out. So it will become v square is equals to omega square a square minus x square. So this is the second equation that we got in this. So first equation we have this. Just a second. First equation is this. Second equation is this, acceleration and this. And third equation we have this. V square is equals to omega square into a square minus x square. This is equation number. Now you can also write this equation as v square is equals to omega square a square minus x square. So v square is varying with x square, you can see here. Omega square you can multiply inside, it will become omega square x square. Now if you divide this whole expression by omega square and take this in LHS, so it will become v square by omega square plus x square by 1 square equals to a square. Now this is the equation of, ellipse. And how does ellipse look like? You know, ellipse look like this, an oval shape. Okay. So variation of velocity with x square with displacement from mean position will be in the form of ellipse. So if you see the graph here, the graph between f and x, and these are the displacement graph. So equation we have this. This is a straight line equation passing through origin, because there is no term c here, or the value of c is 0, which is the intercept on x and y axis. So this is simply the form of y is equals to mx. M here is the slope of this line, which is minus k. Minus matlab negative. So this line you can say has the negative value of slope. Okay. And this will be a straight line. So this is the variation of force. Now if you talk about the maximum value of force, this, it will be, if the extreme positions are A, so it will be Ka minus plus Ka, and it will be here, it will be for A minus Ka. Okay. And for this, it will be minus A. So that is why it is becoming K. Now, Vnx curve, I have told you that this equation is the equation of ellipse, v square by omega square plus x square by 1 square equals to a square. So this is the variation of velocity with x. We can say that when x is equals to 0 here, the value of velocity you will see here. And here the x is not 0, x has this value, this much, which is the extremities. Okay. So at this extreme position at A, the value of V will be 0, you can see here. Got it? As we move away from the origin, the value of velocity will value of velocity is decreasing. So that is why I'm saying that at extreme position, the velocity will become 0. Okay. Now, so this is clear to you, the displacement equation. If the displacement equation is clear to you, then we will move on to the time equations. Okay. So any kind of doubt if you are having in this, just let me know in the chat box. Now, time equation in SHM. And these, I think you have seen in your regular classes. If you have completed this chapter in your regular classes, these you can relate. Okay. Okay, that we have studied in the SHM. So time equation is nothing but we will observe the displacement, the velocity, the acceleration, and the force with respect to time. That how they are varying with respect to time, how the displacement is depending on time. So you know that we have find out the solution of this equation, f is equals to minus kx, and we have related with like acceleration is minus k by m into x. Then we have did d2x by dt square minus k by m x, and we have solved it. We got these two equations, a sine omega t plus delta and x is equals to a cos omega t plus delta. Now I will tell you what it is. Let's just get the postmortem of this equation. X is equals to a sine omega t plus delta. Okay. Now here x is the displacement. Displacement from mean position. Okay. Got it? Now, what is the maximum value of this expression? What is the maximum value of this expression can get? Tell me, anyone? Santosh, student of JNV Haveri, tell me, what is the possibility of maximum value of this x? Anyone can guess? Otherwise, I have to guess it. Got it. So here you will see this a is some constant, only x depending on this sign. So do you know the maximum value of sine theta? This you can assume complete value is a theta. It is written inside the sine function. So maximum value of sine, when this sine will attain the maximum value, this x will attain the maximum value. And we know that the maximum value of sine theta is 1. Sine varies from -1 to 1, na? Come on, guys. You remember this. Sine varies from -1 to 1. Okay. So the maximum value of this function it can get is 1. So that will be the maximum value of x. So x max you can say is nothing but a. And that a is termed out be the amplitude of SHM. Okay. And amplitude is nothing but the maximum displacement from mean position. From where? Mean position. Okay. Got it? Now we have clear one thing. What is A? A is the amplitude and amplitude is the maximum displacement in SHM. From where? From mean position. Okay. Now let's talk about this omega t plus delta. Omega t plus delta is said out to be the phase of this equation of or SHM. Okay. Phase tells us about it tells us about the status of system executing SHM. So that system which is going in to and fro kind of motion, which is executing SHM, this omega t plus delta tells us about the status of that particular system. What do you mean by status? Like if I talk about the WhatsApp status, how they will work, or Instagram story that you will, I think you guys are aware about. So if we are feeling sad, then we will apply the very sad status that life is nothing, life is full of sorrow. So we will apply that kind of status in our WhatsApp or Instagram story. We share with our fans and they will say us that, oh my God, you are suffering so much. Okay. That kind of situations. If we are feeling very happy, then we will put life is everything, life is such a beautiful thing. We will put those kind of status in our WhatsApp. You guys also do that, na? Sometime. Come on. Don't be shy. You guys have do it. I know. Okay. Don't be shy. So what are the status? What the functioning of the status is? They are telling us, they're telling your friend and whoever who's seen that status, they are telling those people that how you are feeling, in what state you are. Okay. So that is the value of status. So in the same way, if I talk about SHM, SHM may we have a body which is executing to and fro. So this phase tells us about where, at what time, at what position our object is, our block is. That is the status in SHM. Okay. You can clearly see here, it is sine omega t plus delta. This time, omega t plus delta, let's say omega t plus delta has a value of 30 degree completely. So sine 30 will be 1 by 2. So x, which is the displacement, is a by 2, which is, we can say that body is in halfway from the extreme position at this particular time. Got it? I hope you got it. So that will tells us about the phase of the SHM, the status of that particular system which is executing SHM. I hope you got it. Now, in this phase, what is this delta specifically? This delta here, and sometime it is written as phi. Okay, phi naught. And this omega t and delta, sometime it is written as phi. Got it? Now, so delta or phi naught, which is here, it tells us about the initial status. Initial status of the system. Okay, and it is termed as phase constant. Phase constant. Got it? Now, I will tell you by doing this. Here, let's say we have a line in which a body executing SHM, and this is our mean position. Okay, and this is our block. Let's say initially it is here, and we are following this equation: x is equals to a sine omega t plus delta. Now, how do you start the motion? If you put, because at the starting of motion, you will say that time is 0 second. T is equals to 0, say we will start the motion. That is predefined. That is no value to discuss here. That why we take T is equals to 0. Okay. Why you take initial height length 0? Why you measure from 0? Okay. So no offense to that. So at T is equals to 0, if you put in this equation, x will be a sine omega t will become 0 sine delta, which means at t is equals to 0, all the things will depend on this phase angle where the body is. Okay, and it is given in the question to you. It is given in the question. Got it? Now, let's say here in this situation, at time t is equals to 0, where the body is, at x is equals to 0. So we can put here x is equals to 0, a sine delta. A is constant, so it cannot be 0. So sine delta will be 0. So delta will be 0 degree. We know that sine 0 will only happen for 0 degree. And the multiple of 2 pi. Okay. Got it. So for at time t is equals to 0, body is at 0 position or 0 displacement condition. The body, you can say it at the mean position. Now you can see how the delta will change if the status will change. Let's say at t is equals to 0, body is at the maximum displaced position, which is, and do not draw the line, we will mark is at a, and this is minus a. Okay, so let's say at time t is equals to 0, body is at extreme position. So the value of x will become capital A here, which is a sine omega t plus delta. And omega t is always t becomes 0 because we are starting the motion. So it will become sine delta. Now sine delta is equals to 1 because a and a will cancel out. Now what is the value of sine delta? When will sine delta will become 1? When delta is equals to 90 degree. 90 degree or pi by 2. Okay. So look how important this delta is. Okay. So it will given you in the question like in the form of body is starting from its motion. The body is starting its motion from mean position, or body is starting its position from x is equals to this, x is equals to that, which is given to you. And that is important to determine the value of delta here. You can see. Okay. Any kind of doubt, anybody in this? How to determine the value of delta and what is the actual meaning of it? Anyone? Any kind of doubt you can ask. Okay. Now, so this we have did the time equations. So for time equation, we have find it out that x is equals to first equation that we have got, x is equals to a sine omega t, and we are taking omega t plus delta. We can also take x is equals to a sine omega t plus delta, and x is equals to a cos omega t plus delta. I hope the ink is visible to you. Please respond, guys, if the ink is not visible to you. Okay. So x is equals to a sine cos omega t. What is the difference between this? When body start its motion from x is equals to 0 at time t is equals to 0, then we will take this equation. But when body start its motion from extreme position at x is equals to a, time t is equals to 0, if it is starting its motion from this point, then we will take this equation. Okay, got it? Now, or in other word, you can also say, if the body at the starting of motion at t is equals to 0, if body is the equilibrium position or mean position, then this equation will come into contrast. But if body at time t is equals to 0, or when you have started the observing the motion, is it at extreme position, then this equation you will apply. Got it? Now, this is the first equation that we have got. First equation. If you differentiate it, dx by dt, what we will got? Dx by dt will become, what is the differentiation of sine omega t? D by dx of sine x is cos x, and d by dx of cos x minus sine x. Okay, this is differentiation. Now a is the constant, so constant do not involve in differentiation, so it is taken common out. So d by dt of sine omega t plus delta. Now sine omega t plus delta will become cos omega t plus delta. This omega t plus delta you can consider as x. Okay, then the differentiation of omega t plus delta will also happen because it is itself is a function, so it will become omega, because differentiation of omega t will be omega and differentiation of delta will be 0 because it is constant. So dx by dt is v is the velocity. It is a omega cos omega t plus delta. This is equation number 2, second equation. Now what about the acceleration? What about the acceleration? Acceleration, again you need to what? You need to differentiate it. So dv by dt, a omega is constant, d by dt of cos omega t plus delta. Differentiate it. So cos omega t plus delta will become, cos omega t plus delta will become, differentiation of cos x is minus sin x. So it will become minus a omega sin omega t plus delta. But this omega t plus delta will also be differentiated. So it will become omega, because differentiation of delta will be 0. So it will become minus a omega square sine omega t plus delta. This is nothing but acceleration. Okay. Now, this is the equation number 3. So, 3 equation you have got. This one. Got it. Now, I will answer your query. I hope you have that one. That how we have put omega as omega square as k by m. Now, take this acceleration equation minus a omega square sine omega t plus delta. Now, a is equals to, if you take minus omega square and a with this sine omega t plus delta. Now, this a sine omega t plus delta, we have seen it somewhere. Oh, we have find it out. This is the equation 1, x. So, acceleration here is minus omega square x. And from the general equation of simple harmonic motion, we have acceleration is equals to minus k upon m into x. So if you compare it, this is equation, let's say 4. This is equation, let's say 5. So you compare it, comparing 4 and 5, what do you got? Minus k by m minus omega square. This will cancel out. So from here you can say omega is equals to square root of k by m. Got it? That's how we got omega. Okay. Another formula of omega you will remember. Omega is always equals to 2 pi f, where f is the frequency. This is equation. This is a formula. Or you can write it as omega is equals to 2 pi by capital T, where capital T is the time period of the system or oscillation. Okay, this is very important. You will need it. We'll need this equation after some time. So, anyone, any kind of doubt in this? Any kind of doubt? Is it clear to everyone? The time equations of SHM, these 3 equations, how we have did it? If you have any kind of doubt, you can ask. Okay. Now, if you talk about the graphs, if you talk about the graph, so we will firstly plot x and t. This is x and this is t. So we will take this equation, x is equals to a sine omega t, and we will consider that delta is equals to 0 here. So this is the sinusoidal function, and it will go like this. This is xt. Now same way we will draw vt, v and t. So vt equation we have as a omega cos omega t if we consider delta to be 0, which means when the sine will maximum, the cos, it is following cos. So when sine will be maximum, cos will be minimum. So here the sine is minimum because x has 0 value. So velocity will start from here. When it is minimum, it will be maximum. Or you can say simply it is following the graph of cos. We will draw it line by line. This one, this one, this one. We are dotting out the minimum and maximum points. So it will start from here, maximum, go minimum, then again maximum, go minimum, then maximum, then minimum, okay, and so on. Got it? Now, if you follow the acceleration one, acceleration is minus a omega square sine omega t, which means the value, the graph will be same. Okay, graph will be like this sinusoidal function, but the values will be reversed. So AT graph you can draw like this. So same value, graph will be same but inverted. So when this has maximum value, it will be negative. Or you can say graph will start from negative value. At when x is equals to 0, acceleration is maximum in negative direction. Okay, got it? So when if you consider it to be theta, when sine theta is equals to 0, so this has a value of minus a omega square. So graph will start from here. And it will go like this. Okay. And this value is minus a omega square. So these are the graphs xt, vt, and et. I hope you got it. Now move on to the next. Okay. If I talk about the energy in SHM, because simple harmonic motion may we have force, we have velocity. So if it is acquiring some velocity and we have displacement also, the force that we have seen in SHM is a restoring kind of force, which always want to pull back any body to the main position. Right? Definitely executing some of the energies. And these two energy, we know that kinetic energy and potential energy. So if you talk about the kinetic energy, two types of energy we have. Kinetic energy is given by 1 by 2 mv square. Now you put the value of v. You can put the value of v in terms of what? You have two ways to calculate kinetic energy. Same in the form of time form or in the displacement form. So if you put the expression, we have got it. V square is equals to omega square a square minus x square. You can put the same here. So you will have m omega square a square minus x square. So this is kinetic energy in displacement form. Another formula you can take half mv square, and v is equals to a omega cos omega t. So it will become ma square omega square cos square omega t. So this is kinetic energy. For general value, you can take it omega t plus delta. If you talk about the potential energy, so potential energy for spring block system, we are talking about the SHM, which is executing the SHM. So potential energy will be 1 by 2 kx square. So x you can simply see this is itself in terms of displacement. If you want to convert it into time frame, so it will be 1 by 2 k x square go you can write a square sine square omega t plus delta. Okay. Now we know that what this is the equation. We also know that k is equals to m omega square, because omega square is k by n. So if you put that in potential energy expression, you will have potential energy is equals to 1 by 2 times m omega square a square sine square omega t plus delta. This expression you can also keep in your mind. And I am not recommending you to learn these expressions. Just grasp the concept that I'm talking about. Okay. Now, if you talk about the total energy is represented by E given by E given by K plus U. K is the kinetic energy plus potential energy. So if you put kinetic energy and potential energy in time form, so 1 by 2 m a square omega square is common in both, 1 by 2 m a square omega square. So we can take 1 by 2 m omega square a square as common. So the what we have left in kinetic energy cos square omega t plus delta, in potential energy sin square omega t plus delta. And this is nothing but cos square omega t plus delta plus sin square omega t plus delta. And this is nothing but the identity. The value of cos square theta plus sin square theta is 1. So we can say that total energy is equals to half m a square omega square, which is a constant. So the law of conservation is valid in this format. Okay. So total energy is constant in this. So this is it, guys. What we have learned till now. This is it for today. I hope you have enjoyed the session. Okay. Any kind of doubt, if you have, you can ask right now, or otherwise you can leave the lecture. The lecture is being over. Thank you so much for being attentive. Take care of yourself. Bye bye. Have a nice day.